This is Group 35, and our NAE project is providing access to clean water. My name is Tolu Aofiebi.
This is Brenna Garza.
And Nolan Griffin.
So as a team, this topic, providing access to clean water, is really important because around the world, it is important to have access to clean water, be it for domestic purposes or for industrial purposes. Access to clean water is something that creates like a backbone for the country as a whole because you use water every day, every minute, every second, everywhere around, anywhere you're at. The challenge is very interesting because a lot of countries, especially like third world countries, have problems with having access to this clean water that we get over here in America, for example. And it is important that everyone has an access to clean water to improve the standard of living in these countries. Our goal as a team is to represent this data in a manner that makes it easier to solve this problem. We can't exactly use our code to solve providing water in these countries where we can't even get to, but using our code, we can help and aid people who are going to make these changes. So say, for example, engineers who go out to these places to actually effect the changes that we need, we can help them see where it's more important and places that they need to actually be to solve this problem and access to clean water. Take, for example, a country in Africa where they don't have access to clean water, digging wells and boring holes to help, pull water out of the ground. We can show countries that most needs our help, and we can get over there and, solve the problem of drinking water by making infrastructure down there and making sure that the people have what they need.
Okay, for the algorithm to our code, first you'll have to select whether you want to input an ISO code or a country. If you select the country, you'll have to choose one from the menu. If you choose a country, it'll then display the percentage data for that selection, which will be the percent population without access to clean water, the percent child mortality rates, the percent population malnourished, and the percent population below the poverty line. Then it'll take the average percent child mortality, nutrition, and drinking water and display that. Next, it'll find countries above the average percent and store those into a matrix. After that, it'll display a statement listing the countries in this matrix and state that these are the most in need of clean water. Then it'll take the average percent of population below the poverty line, store that into a matrix, and finally, it'll output a statement listing these countries and specify that these are the countries that'll present more of a challenge in providing clean water. However, if you select an ISO code, you'll have to input a 3-digit ISO code. If your code is not 3 digits, our code will prompt a warning statement for you to re-enter that 3-digit ISO code. Following that, it'll output the same information as though you were to select a country. While our code doesn't exactly solve the problem, it does give a method for solving the problem. So the order that everything is outputted, first you select a country and then it'll display certain percentage data. This allows you to see the importance of that country's need for clean water. Next, it'll display percentage of population below the poverty line, and this shows you how easy or how much of a challenge it would be to provide that country with clean water. Say if the country is very poor, it would be a lot harder to get water to that country and make it more accessible to its people. But if that country is very wealthy, then it would be pretty easy to get clean water to their people.
Okay, a typical example of how our code will be ran will be to select a country. So the menu asks the user if you'd like to select a country or enter an ISO code. So I'm going to go ahead and select a country, and I'm going to pick Jamaica as a country from my menu. And after I pick that menu, what our code does, it displays a graph that shows the population with access to drinking water versus child mortality rate, The second graph on that window is going to be population with access to drinking water versus nutrition. And the third graph is going to be population with access to drinking water versus population below national poverty line. Then the code asks you again, would you like to select another country? So I'm going to go ahead and say yes. And then the menu asks, would you like to select a country or enter an ISO code? So now I'm going to click and enter an ISO code. And I'm going to type in NGA, which is the ISO code for Nigeria. So I'm going to put NGA and click enter. And it's going to ask me if I want to select another country. This time I'm going to say no. And after I say no, the output to the command window is finished. And our graph is still shown for both countries now. So that's the country that I selected first time and the second time. In the output command window, we can see that it gives us information about the first country that I selected from the menu and the second country that I entered the ISO code for. So that's Jamaica and for Nigeria. So those two give you the information for the child mortality rate, the percent of population deprived in nutrition, percent of population deprived in drinking water, and percent of population under the poverty line for that country. So you get those two informations, and then we also have in the command window the countries above the average percent of population deprived in drinking water. So that's all the countries out of our list. And we also have further down below that the country above the average percent of population deprived in nutrition. And finally, we have the countries above the average percent of child mortality rate. Okay, so what I'm going to do is go ahead and run the code again using a different scenario. So I'm going to start and enter an ISO code for the menu that asks me if I want to select a country or enter an ISO code. So for the ISO code this time, I will be using GHA, which is the ISO code for Ghana. And after that, it's going to show me the graph that has those three subgraphs on it. And I'm going to say nope. And now the command window is complete. So the difference between entering an ISO code and selecting the country is just the type of information you put into the code. So it doesn't matter which one you start with. You can enter an ISO code first or you can enter a country first. You will still get the same information. The length of the output on the command window depends on how many times you run the code for how many countries you run. So say you do the ISO code 3 times, you're going to have 3 countries before the list of each category on the output command window, if that makes sense. So this time I only ran it once and I only have Ghana shown on my output command window. But if you do it multiple times and ask the code to be ran multiple times, you have multiple countries being shown on the command window. So for any user who uses this code, your output doesn't really change depending on how many times you run the code. It only changes if you do a different length, and that's just about it for this code.
I would now like to speak on the limitations of our code. 1, our code is a database, a source of information which does not actually provide any water to any inhabitants of any country. 2, our spreadsheet may not be up to date since the source of information is a website based off of 2014. 3, our code only outputs information through 104 countries versus all the other countries that exist in the world.
We would like to conclude by stating that we hope in the future our code can be tweaked to better display the needs of countries, maybe not just in terms of providing access to clean water, but solving other problems around the world.